Okay, no, let's get it. Good. All right, we're good. So last time, I feel like I've been not even stuck, but just going over the same stuff a whole bunch, just to get these templates in my brain. Like I think even last time, did I even go into having multiple template parameters? I probably did, because if we have one with multiple, or if we have a template with only one template parameter, but multiple variables of that type, of that placeholder type, well, it would have to pass we'd have to call the function or the primary template with the same type. No matter what, doesn't matter what the type is, but two of the same type. Otherwise, we have an issue. If we're calling an int and a float, and they're both template parameters, then we have to have two different placeholder types because the types are differing. And again, um, the primary template will not check for semantic correctness. It will simply generate the specializations, which may not be valid, depending on what we're doing with the information. Okay? Oh, wait. This is where I was. So, you may be surprised. Oh, wait, that's it? That's how far? Okay. Well, yeah, duh. The compiler isn't going to work. Why? Because we're saying, hey, we have a template guy here, okay? We got a primary template, this guy. Well, it has one placeholder type. Oh, well, guess what? And these two variables, these two parameters, are of that same type, which means we must call it with the same type here. These two must be the same type. They're not in this case. So nothing is matching. Makes sense. Oh, and for the ambiguity, I'm not really sure about the ambiguous part. I'm thinking that it could make an int, and a double specialization, but that should be the only one. So it should then try and call that, but it can't actually because they're the same type. So I guess it's saying we can't create one, and if there's no function, there's no matching overload. Because we're calling max, but there's no version of max that works. It's ambiguous because it doesn't know what to call because there's nothing to call, seems like. Excuse me. Could be double or int, so this seems like this connects to here. I was thinking for a second that we might have some conversion stuff going on, like, hey, does this, if there were two versions and one of them was double double and then one of them is double or int double, then well, does the int get converted to the double and then called? It seems like in this case we just fail. It can't deduce the type, the template argument for t from double because it's already seen this type that's an integer. So it's wondering, why is this guy a different type? We have an error here. We don't have two type names. We need two type names here. Boom and boom. We need T and Q or something. We can't have two of the same for this call. We can't call it. It's not a valid call. So in this case, we could just say, hey, if we want it to be the max of two of the same data type, then make a, well, how would that work? Could we make another, I guess we could. We could make another template and have multiple types, and then we just delete that. That way, if we call it with two different types, then it doesn't work. It's disallowed. But in this case, we probably want to do this, so therefore we have to have the primary template correct. We need two type names. That way the call arguments can differ in data type. Mm-hmm. Yeah, it'll check to see the non-template. Makes sense, but we don't have one. Yep, sure. It'll check for some template shit, but it'll see that it can't create anything. Yep. Yeah. Mm-hmm. Yes. That's the important part, I think, here. Yep. Why it didn't generate this function max double double? I don't think. Yeah, exactly. We don't get type conversion for creating specializations. We only get it once we have multiple specializations to determine which one we're calling. So there needs to be an exact match here in order to actually generate something. But if different ones already exist, we could get implicit conversion action going on whenever we're actually calling a specific one if there is a match. But in this case, there isn't anything, and it can't generate anything because it needs to generate something like this with two different types, but it can't because its rules don't allow it. It's only done when resolving, not when doing template argument deduction. Make sense? Yeah, it makes sense. So like if I have a function that requires a character attacking a character, I have to call it with a character and a character, or at least something and a something, not a something and a something, not an X and a Y, it's an X and an X, or a type T and a type T. It can't be a type T and a type Q, and we can disallow them explicitly. The fuck? The ice maker is going crazy. Well, yeah, so we could fix the call, sure. If we're calling a TT parameter guy with a float int, we can convert the int to a float or a float to an int, and then it's a float float or an int int. Okay. I think that's a bad way of doing it because we're just updating a fucking call instead of updating the function to handle or disallow the shit. Sure. We can do an explicit template argument. What the fuck do you mean? Oh, meaning making an explicit specialization? Is that what we're saying here? Oh, where you're saying if we make an explicit one to be double double, then this int will be implicit, or well, it'll be numerically converted to a floating point value. Okay, so if we have double double, we can call it with an int double because it already exists. The type deduction is double or int double. Okay. We're trying to call a function with this. Okay, well we just do type conversion. But it has to explicitly exist in order for us to convert to it. Yeah. It gets converted? Sure. Yeah, it's numeric conversion. Well, if we're doing an explicit call for int double, or well, oh, I guess if we're doing an explicit call with one type and it's double, then it'll convert the int to be a double. So we could cast it, or we could call a template of this type, and it will convert the arguments to it. Because we're specifying the type name, actual type, what the type name should be. So do we get an issue if we do this then? Oh, oops, hold on. We didn't. Well, in this case, we just don't have it. If oh, here we go. So if we did a non-template version, then it would convert like normal. But here, when we're doing a template one, the issue I think is that we weren't using the type name in there. Oops, this isn't a template, so don't need it. And I could call do thing with a 1 and a 3.0. And it's still going to call void do thing because this guy gets numerically converted to a floating point value. But if we do template, hold on. If we do 3 and 3.0, the issue here is nothing is matching. But if we convert them to be the same type, then we're saying, hey, excuse me, don't look at these as two different types. Look at them both as this. So it's like a shortcut to casting. Seems like. Or rather, it's a shortcut to. Yeah, I mean, it seems like it almost is a shortcut to casting. It's a shortcut to converting the arguments to be of the same type or of specific types, in this case, the same type. That way, the specialization could generate one of the same type for both argument or for both type template parameters, and then we're good to go. Yeah, so if we call it normally without the explicit part, explicit template call, issue because these two are different types, these two are the same type. But if we specify double, these are no longer two different types, just like if we casted one. Yeah, instead it creates the double version. Makes sense. It sees two parameters or two arguments, so it does a double this, a double that, so a double x, a double y. We're calling double x, double y with these two, and then 2 gets converted into a double. Okay. So this isn't saying what to convert these to. This is saying what the specialization to generate. Then we call that specialization via this syntax. And thus we're calling a function with double parameters with an int. And thus the int gets converted to a double. Make sense? If we didn't have to think about the types, then we could just make the template so that it handles different data types. Make sense? Excuse me. Yeah. Yeah, make it so that they can. Make sense? Because then if they're the same type, it's okay. If they're different, it's also okay. Yep. 2 and a 3.5, it's okay. One of those is a T and one of those is a U. We're cool. Yep. Yep. It'll create that specialization. I'm trying to pop my right knee. Damn. Cool. Yep. In this example, it's that and that. It's saying return if x is less than y, return y. Well, 2 is less than 3.5, and it returns should return 3.5. Oh, hold on. But the problem is that we have. Wait, really? Hold on. X is less than y? Yeah, but shouldn't the int be converted to a floating point value and then we just return the floating point regardless? Oh, or hold on. Oh, it's the returning part. Okay, I understand. In this case, we've specified which one. I'm used to doing void, so I'm not returning either of those. I like void functions. In this case, we're returning a t, and the problem is if x is greater than y, then we return x. But that means when we've called this guy, or hold on, we've called this guy, so x gets 2 and y gets 3.5. But then we compare them and we get a common type. So x goes from being 2 to 3.5 because we have to operate on 2 of the same type. So x has become the value. The value has become a floating point value. But now we're returning a floating point value as an int because that's what this type t is. So we get an narrowing conversion there. Okay. And we're also getting a 3. Oh, true. Well, okay, so maybe, hold on. I think it might be the same too in this case for, let's say it's min. If x is less than y, we return x. Well, 2 is less than 3.5, but I'm pretty sure there's a common, well, actually, maybe not, because I think it's the usual arithmetic operands. I think the common type thing might only be applicable for plus, minus, subtraction, plus, minus, multiplication, division, remainder. Assuming that's the case, if y is greater and we're returning y, well, look at our return type. Our return type matches x, not y. And if y, or if u, is a data type that doesn't fit within t, then returning u as a data type of t yields a narrowing conversion. So in this case, 3.5 is the maximum, but we're returning 3.5 as the data type of our x argument, our first argument. 2, an int, we're returning 3.5, a double is an int. A double implicitly converted to an int is a narrowing conversion. And if we turn the narrowing conversion issue off, oh, finally he's mentioning this shit, the setting again. Makes sense. We're returning 3.5 as an int. We drop the floating point. We get a data loss 3, because an int can't represent the data loss or the decimals. Oh. Well. The result of the conditional operator we'll also use the common type. The common type of an int and a double is a double. So it's actually, it also works for my thing too. So that's cool, but the problem is that. So in this case, I'm actually right times 2, I think. That means that 2 and 3.5, pretend this is minimum. Well, if this is x is less than y, return x, otherwise return y. Well, and we return x. Well, the return result of this guy. Oh, well, hold on. If we're talking common types here, well, I don't know if this returns the implicitly converted value or not. It seems like it does. The result of the okay, so it's saying the result of the whole conditional operator, the whole thing. It's the ternary operator. It has 1, 2, 3 operands, this whole thing. And it says that the return result of this whole thing, due to the C++ standard, returns the converted value. So we find the common type between x and y, and we return a value. Even if x is 2, and then it becomes 2.0 here, we're returning 2.0, not 2. We return the common type value. We're basically saying, hey, this less than this, return this. This less than this, return this. Don't let return 2, return 2.0. So, if it was min, we'd also get a nearing conversion, because it's numerically converted, but then we get a narrowing as we go back. Yep. Yeah, and t is an int. We're returning a double to an int. Or as an int. Yep. Yeah. I mean, regardless, it just depends on what the value is. You're just screwed depending on what values the call has. So if we did auto, then it would see what the return value is and then return it as it is and not convert it back to whatever it saw in the beginning, which might be narrowing to go backwards and convert to it. It wasn't narrowing to go from int to double, but it is to go from double to int. So we could do that. Interesting. Yeah, so we could say, what's an example here that would be good? Like maybe the attack damage is of a floating point type, because yeah, maybe like as a character levels up, it has resistance to damage, or it can develop resistance to damage, and as it levels up, eventually that increments. Just like in D&D, for example, maybe you have like your armor class is this, and then at some point, once your dexterity increases another 2 levels, oh, you have 1 more added to your armor class because it's your whatever you call it, your modifier. Okay, so sometimes information about a character increases and is best treated and stored as an integer, but other things could be best treated as a float. So maybe we need to because we have a bunch of damage multipliers and modifiers, we need some decimal modifiers. We can't just multiply things by integers. 1 or times 2 and 3 and 4, we get big ass numbers. So we would multiply by 1.05 for 5% more, and 1.075 and that kind of stuff to get gradual increases. That way, if you equip a piece of equipment, you're not automatically doing a minimum of 2 times more because that's the smallest int that's greater than 1. 2 times damage to equip these gloves of a little bit more strength. 2 times? That's a lot. So damage naturally needs to be a floating point value. That way it can be gently increased. But whenever we attack a character and our attack is subtracted, or and the resistance is subtracted from the damage. So if we do 3.8 damage and the character has damage resistance of 3, we subtract 3 from 3.8, we get 0.8 damage. Well, if we left that as an int and a double, and we happen to return the same type of data as the damage resistance, we would be returning a float, the damage, or the damage result, so the common type between the int and double, just like this case, very similar, it's almost identical, is a double. A double and an int. Double is the common type. So if we happen to be returning the damage, which makes sense, you return the type of damage or the type of data that the damage. Well, if you return the type of data that the damage is, we're okay. But if we happen to accidentally return the type that the resistance is, then we're converting 0.8 to an int. Oh, and we get 0. So it looks like, oh shit, he had 3.8 damage resistance. We did no damage. In reality, we should have done like 25%-ish, a little bit less than that, like 22% of our damage. But instead, we're doing 0% of our damage because we're losing data for the result of damage. So we could use auto, or we could just smartly return the right result. We can return the common type. We're not returning the initial type. We're figuring out the common type in advance. We're saying, hey, in this, it's probably the case that at some point there's an int getting passed to the template. It's probably a double or a floating point getting passed to. We know the common type has to be a floating point. Therefore, we pass it whatever the floating point is. But the problem is, if we choose X versus Y, well, we might call it in one. Well, no, because the parameters are the parameters. We're going to pass it. We're not going to pass it to random values. We're going to pass it the values, or in a random order. We're going to pass it them in the correct order. Because if we passed it damage of 3.8 and the damage resistance of 3, and we subtract Y from X, we subtract 3 from 3.8. But if we passed it instead resistance and then damage and subtracted Y from X, damage from damage resistance, we get negative 0.8. So are we applying negative 0.8 damage, or positive 0.8 damage? Well, it depends on the call. So we can't return X or Y because we don't know what the call is going to be. Well, no, we should know what the call is going to be. We should know that, hey, the damage is X. We're subtracting from X. Return X. X is always going to be the floating type. But what if we pass X, we pass the damage as an integer? And then what if someone eventually gets a freaking non-incremented, a non-integer damage resistance? And now we're returning the damage. And we have the common type of a floating point, but we're returning the damage, which in this case was passed as an int. We get a narrowing conversion. So we could use type deduction to fix this. So we could say that, hey, there's a template and it has a type named T and a type name U, and we have an auto returning apply damage, and it's T and it's damage, and a U damage resistance. Okay. And we could give it default arguments, but in this case, maybe we want to pass it who's attacking and what's going on. Oops. Let's get some IO stream going on. Character output. Cool. Let's get a little namespace action happening. We'll just say character values, or okay. we'll say, if not defined, character values, define character values, and if namespace character values, and then we'll say a const expression int. In this case, we're going to do an inline const expression int, because otherwise, if we include this as a const expression int, each file we include it in gets its own local piece, which means that we're storing the same information, this const expression that can't change, in different pieces of memory. We're wasting memory. And we'll say player damage resistance. We'll say resist, and let's say he's got 10. He's pretty high level. And then we have a non-const value, and we just call it double player current damage, and it's 100.43. Okie dokie. And now include character values. Okay. And we're going to say character values. Oops, hold on. And we're going to return damage minus damage resistance. And auto will figure out, hey, what's the return type here? Oh, well, hold on. U and T. Is it T or is it U? We don't know. It depends. If this is an int, this is a double, it's this guy. This type we're returning. If this is an int, this is a double, it's this type. Well, if we always want to return this guy's type, well, I mean, we want to return whatever type preserves data. So, and now we will output damage dealt, apply damage. How much damage are we applying? We're going to do character values, and it is player current damage, and character values, player damage resistance. Okie doker. And it should be whatever it is, like 90 point whatever. Yeah, cool. All right, good. It returns the common type. We don't fuck up and instead return a U type, because then, boom, possible loss of data. Why? Because damage is 100.43, damage resistance is 10, 100.43 minus 10 is 90.43, but we're returning the type of the damage resistance, an int. So we get a double result and we're returning a double as an int. Narrowing conversion, bucko, no sir. Okay. So we could use type deduction. Oh yeah, and the reason here, oh, does that mean we can't forward declare it? I don't remember if that's what it means, that we can't forward declare. It's been too long since I did an AI quiz. I've just been gone for a sec. It's been like a week. And I've been starting but having to catch up on sleep, so I didn't have time for the quizzes. And this is more valuable, I think, than the quizzes are important at keeping info, but I also need to learn new shit. So, and the other shit's already pretty locked in. So, can we? Let's find out. What happens if we do an auto do thing? Boom. Oh. Oh, it's actually okay. But if we say do thing, cannot be used before it is defined. Therefore, we can't forward declare it, it looks like. Looks like we have to do some inline auto shit. And the reason for that is because the compiler sees, hey, you're calling this function with these types. What the fuck am I returning here? I only see auto. I don't know what type I'm returning because it needs to exist in my definition. Which means this function needs to be probably inline in a header file. That way you can include it here and include it elsewhere too. Well, yeah, because if you include it in multiple places and it's not inline, the compiler is going to say, hey, buddy, you have this guy defined in a header file because you can't do anything but define him. You've defined him, included him, but you've included him in multiple files. We have an issue with that over here. So you can't have two definitions of the same shit in the same scope, and functions are in global scope. So we got a fucking problem, mate. Yep, a for declaration won't suffice because it needs to know. Yes, makes sense. Compiler needs to know. If we need a function that can be for declared, we have to be explicit about the return type. Okay? Oh, we could do some trailing shit. Oh, and we could get a common type between those two, and it'll say int and double. Oh, it's this one. This and this. Oh, it's that one. And so we could have a template. Oh, so we could have the for declaration, but it's not auto. It's just a trailing. Well, we don't need auto here. I mean, well, I guess we're doing it because it's easier, I guess. It's more readable, maybe, but I don't like it because then it makes me think, oh, hey, I'm returning some auto stuff and it's determined to, oh, no, it's just this. And this is already known at compile time because we see the calls at compile time. And the data types of variables are known at compile time. Yeah, so we could do standard common type T to get the common type. Type traits? Yeah, I guess so. And so we could do a template type name T, type name U, and then a standard common type T. Oh, between types, because types are in the template shit. T and U. Do thing, and it takes a TX and a UY, and if we say return X minus Y, and in this case it's calling the int double version, which returns double. Why is it returning double? Because this is some common type shit. It's determining this here based on what it receives. We say, hey, 3 and 3.4, prioritize a non-template. Prioritize non-template if it exists. Oh, it doesn't exist. Okay. Template type deduction, argument deduction. Do your magic. Okay, we have an int and a double. Okay, T's an int, use a double. Okay, what's the common type? Oh, okay, it's a double. We're returning a double. Okay, so we get X and Y. Okay, we convert that to a double. Oh, it's already a double. Okay, cool. And maybe that's better because then we could say in some other file we have standard, oops, we'll just do type traits, and we'll do standard common type T. Oop, and we need the template type name T, type name U, do thing TX UY, and we have return X minus Y. common type T of what TU. An unresolved external, but buddy, this is the for declaration, no? So what if we did this? So this is cool. This is not cool. Seems like it's the same shit, like it's required anyways. Fuck. I think I opened Darkest Dungeon. Nope. Was I just fucking it up? What was happening here? Common type T, U, do thing. T and a U. And it's for declared here. And we're getting an issue in main because it says, hey, the definition is not found. So it's not treating this guy as a for declaration for some reason. So what if we said auto same shit. Okay. Seems like, I don't know. It has internal link. Well, it's not internal linkage, but it seems like this isn't right. It has to be in the same file. So the point is that auto literally can't even be forward declared. This can be forward declared, but it still has to be in the same file. Abbreviated function templates? Oh, okay. It'll automatically convert the function into a template. Okay, so this is effectively type name something and a something and then auto, seems like? Yeah, exactly. Makes sense. Auto, auto, auto. It's saying, hey, don't necessarily return the type of X or the type of Y. Return the common type. Return what you need to return. In this case, depends on which one's greater or less. This is, well, yeah. I mean, well, it doesn't matter. It actually, yeah, it doesn't matter. It returns the common type. Same shit. Okay, so we could do it that way. In cases where you want each template type parameter to be an independent type, this is preferred. Meaning, it's actually preferred to do the abbreviated function template, meaning auto is preferred. There isn't a concise way to do abbreviated ones when you want more than one auto parameter to be the same type, meaning that we want to disallow them to be different types. Well, in this case, if this is a different type than this, we're returning the common type in this case. There's nothing here that says, hey, if this is X and this is X, Or like, there's nothing saying that these have to be different or that these have to be the same. They can be independent. It's just like type name T and U. There's nothing saying that, hey, type name T and T, they must be the same. Yeah, there isn't anything to say T and T. They must be the same. And maybe we delete this one. There's nothing. We would have to do a template to say, hey, if these two are the same type, unless there's some sort of condition logic that exists, then no bueno. So use the abbreviated with a single or where each should be an independent, meaning that it doesn't need to be the same type. I think we already know this because we can have the function template action, but then we can also have regular overloads. And if we do a regular function call with parentheses alone and no template syntax, then we prioritize the overloads that are non-templates. If we don't provide explicit specialization or explicit template call, I guess, we don't say what type of template that we're looking for or specialization to generate or look for, then we're not using type deduct. Or if we do that, then it will say, hey, generate one of this type specifically or these types specifically. If we say call, so we say do thing int float 2 14.3 f. Okay. And we'd have to put the f because otherwise we get a narrowing conversion from the double to the float. So then it will try and call explicitly only the template version. It'll ignore any regular non-template overloads. Or we could do the type deduction by doing the empty angle brackets together. And that will only do template still, but it will do type deduction instead of explicitly making a specialization and calling that one and using conversion if we need. And I think that's it. I fucked the glasses up a little. Damn, I keep doing it. So we could do a normal call to prioritize non-templates. We could do an explicit specialization call to generate a specific specialization and try it. Or we could do type deduction still for templates only. So there's type deduction for anything, but prefer non-templates. Type deduction for templates only. And then explicit for templates only. Yeah, so we have a single type for x and y, and we return x and y, and in this case it's doing auto, which doesn't matter because they're the same type anyways. We could also do two distinct types, or we could do auto, auto, auto. Return an auto, and then the two parameters are of autos, so they could be distinct and it's fine. We could do this. And then we could also do another one that has 3 type names. This. So if we call one with 3, well, we know it's going to call this last one. We could also call it, with the template specialization syntax so that it generates a specific one, an int float and a double, and calls that one. Or we could let it make its own depending on what we have. Or we could let it do its own, except prioritize non-templates. So we could do one type or another type or another type. So if we give it an int, it calls the first one. There's only one. It's the same type. Oh, we have one with 2 distinct types. Okay, we do another. So if we have 1.2 and 3.4, they're both doubles. It's going to call the first one. Oh, we have 5.6 and 7. Oh, it's going to call the second one because they're 2 different types. The first one is not 2 different types. The second one is. The third one's 3 parameters, so no bueno. And the last one has 3 arguments, so it's going to call the 3 parameter one. Cool. For 1.2 and 3.4, it will prefer that over that. Well, yeah, it makes sense because it's a more close match. Hey, we're calling the one that has 2 of the same type. Okay, these 2 could be the same type, but we need to resolve when that happens. When we have one that's slightly less accurate, it's not... I guess it could be an exact match, but this one already exists. So when we call it, it'll say, hey, this is a double and a double. Oh, this guy matches a double and a double. Boom. If this only existed, then we'd be cool. So this is like a closer match to the argument. Partial, or hold on. The rules for determining which of multiple matching function templates non-type? Oh shit. Partial ordering of function templates. Whichever one is more restrictive specialized is preferred. Yeah, meaning if it matches. If it matches one that's very specific, then boom. So TT. Yeah, because it requires them to be the same type. If multiple, it goes to be more restrictive if it can't tell. Like if we had a T and a U, but we also had a P and a Z, well, they're both two type names, and they both could be the same type, but they could also be the different type. Oh, well, we don't know which one we're gonna do. In this case, this is more distinct because these are two possible different types. Okie dokie. Seems good to me. Okay, I'm gonna pause real quick and then come back.